Assalamualaikum. My name is AHMED and it is a group presentation with my group members KASHIF and SOHAIB. Our topic is about transportation model at about maximization and minimization. At first, what is a transportation model and when it's come? The basic transportation problem was originally developed by Alfred Hitchcock in 1941 in his study entitled it is called the distribution of a product from several sources to numerous locations. Now, what is a transportation model and why it is used and what is it related to? The transportation problem is one of the subclass of linear programming problem where the linear programming problem where the objective is to transport various quantities of a single homogeneous product that are initially stored at various origins to different destinations in such a way that the total transportation is minimum. What is the purpose of transportation model? The transportation model or problem are the best primarily with the optimal best possible way in the which a product produced at different factories or plants called supply origins and transported to a number of warehouses called demand destinations. The other purpose of the transportation model is the object in a transportation problem is to fulfill and fully satisfy the destination requirements with the operating production capacity constraints at the minimal possible cost. What are the steps of solving transportation model? First step is to formulate the problem. The second step is to balance the transportation model. If it's unbalanced, it has a maximization or a minimization function, we have to first balance the transportation table. Then develop the initial solution using the northwest corner method or least cost method. Calculate the improvement index for which the empty cell is using either the stepping stone method or the Modi method. If the improvement indices are all non-negative, stop as the optimal solution has been found. If any index is negative, continue to step 5. Select the cells with the improvement index indicating the greatest decrease in cost. Fill the cell using the stepping stone path and go to step 4. Minimization. It is also called the total capacity of supply exceeds total demand. What happens if the total supply is exceed from total demand? In this case, we will introduce a fictitious destination with demand equal to the difference of total capacity and total demand or at zero cost of transportation from source to fictitious destination or dummy column or add the transportation algorithm to find the optimum solution or introduce a dummy demand destination. These both are equal thing. After that, we use the same steps as we discussed in a previous slide, like the steps from 1 to 5. In maximization is also called the total. If the total demand exceeds, then the total capacity. In this case, we also introduce the dummy or a fictitious row as necessary with the cost of coefficient 0 in order to solve it. Maximization problem may be solved by using following method. Then multiply the given payoff matrix of profit or gain by -1. Then use the transportation technique for minimization to obtain optimal solution. To calculate the total profit or gain, multiply the total cost by -1. Now that's all for me. Now I'm inviting you to my next member, Kashif Khan, to continue this presentation.
Assalamu alaikum. My name is Kashif Khan, and today my topic is what happened if supply exceed demand. First of all, this I can explain this situation occurs when the supply of a factory rises than free demand. Now we explain it we if it with an example of practical scenario table. First of all, I explain table. The टेबल सबसे पहले सोर्सेस आ जाती हैं और उसके बाद डिमांड जो सोर्स वन होगी उसके अंदर पहले जो डिमांड आएगी वो 10 होगी, जो डिमांड टू होगी वो 15 होगी और जो डिमांड थ्री होगी वो 22 होगी और इसकी जो टोटल कैपेसिटी आ जाएगी वो 15 हो जाएगी। फिर आ जाएगी सप्लाई सप्लाई टू हो जाएगी, उसमें जो डिमांड वन होगी वो 9 होगी, डिमांड टू होगी वो 0 वो 8 होगी और जो डिमांड थ्री होगी वो 3 हो जाएगी और इसकी जो टोटल कैपेसिटी बन जाएगी वो 25 हो जाएगी। नेक्स्ट आ जाती है सोर्स थ्री, उसकी जो डिमांड वन होगी वो 12 होगी, डिमांड टू जो होगी वो 8 होगी और डिमांड थ्री 20 आ जाएगी और कैपेसिटी 45। देन उसके बाद डिमांड जो टोटल डिमांड आ जाएगी वो 20 हो जाएगी डिमांड टू की, वो भी टोटल 20 हो जाएगी और जो डिमांड थ्री होगी वो भी टोटल 30 हो जाएगी और फिर कैपेसिटी आ जाएगी 85/70। देन आ जाएगी नेक्स्ट है एक्सप्लेनेशन। As the above table showed that the total supply is 85 while the total demand is 70. So supply is greater than demand. Per unit cost of transportation from the source of supply 1 to demand 1 is 10 rupees. Per unit cost of transportation from the source of supply 3 to demand 3 is 20 rupees. Now we observe the above illustration and try to minimize the transportation cost when supply is greater than demand. Next, value of DF. In this situation, first of all, we present a dummy demand to fill the group between demand and supply, that is 85 minus 70 is equal to 50. Now we will try to meet the demand and we can use the same transportation algorithm to find optimal solution. For the purpose, we draw another table in which we present another block of DF. Example, next table आ जाता है जिसमें सोर्स होगी, जो सोर्सेज आ जाएंगी वो S1, जो उसमें जो डिमांड वन होगी वो होगी 10, डिमांड टू 15 होगी, डिमांड थ्री 22, डिमांड फोर जो होगी वो DF 0 हो जाएगी। देन जो उसकी कैपेसिटी होगी वो 15 आ जाएगी। उसके बाद सोर्स टू आ जाते हैं, उसमें जो डिमांड वन होगी वो 9 आ जाएगी, डिमांड टू वो 8 होगी, डिमांड थ्री हो जाएगी और जो DF होगा वो 0 हो जाएगा और कैपेसिटी वो टोटल 25 आ जाएगी। इसी तरह सोर्स थ्री में आ जाएगा, डिमांड वन में 12 आ जाएगा, डिमांड टू 8 हो जाएगी, डिमांड थ्री 20 और जो DF होगा वो 0 और जो टोटल कैपेसिटी होगी वो 45 आ जाएगा। इस तरह जो डिमांड जो टोटल डिमांड आ जाएगी वो D1 में 20 हो जाएगा, D2 20 वो भी 20 और D3 30, DF 15 और इसी तरह कैपेसिटी जो हो जाएगी वो 85/85 आ जाएगी। देन जो नेक्स्ट है वो मेथड आ जाएगा। What is 15? Actually, the 15 is a dummy demand is ordered to meet the supply and per unit cost of transportation is 0 because we show a dummy demand, so there will be no transportation cost. Now we use it be a method of northwest west corner or least cost method. Then आ जाएगा next जो होगा least cost method आ जाएगा। उसमें जो the least cost method is another method used to obtain the initial a feasible solution for the transportation problem. Then जो next होगा वो epsilon आ जाएगा। उसमें जो the Greek letter epsilon written is just another variable like x, n or t. it is used to donate, and here we use to epsilon to calculate the value of variables. The calculate the variable of u1 and v4. इसी तरह टेबल आ जाएगा u1 plus v4 is equal to 0 हो जाएगा, एंड u2 plus v3 is equal to 3 आ जाएगा. इस तरह u3 plus v1 is equal to 12 हो जाएगा, u3 plus v2 is equal to 8, u3 and v3 is equal to 20. और जो नेक्स्ट टेबल होगा उसके बाद नेक्स्ट आ जाएगा टेबल, उसमें हमने टेबल बनाना होगा. इसी तरह उसमें पहले सोर्सेस आ जाएंगी, फिर डिमांड. जो सोर्स वन में जो डिमांड वन होगी वो 15 हो जाएगी, और 15 और 10 हो जाएगी. और D2 में -9 और 15 होगा, D3 में -4 और 22. इसी तरह जो इनकी फिर टोटल कैपेसिटी आ जाएगी 15, कैपेसिटी में आ जाएगा 15, U1 इज इक्वल टू 15. इसी तरह सप्लाई 2 आ जाएगा और इसमें डिमांड 1 आ जाएगा. उसी तरह -14 होगा और 9 आ जाएगा, डिमांड 2 -17 8 हो जाएगा, और D3 इसी तरह 25 और 3, और DF -17 और 0. इसी तरह इनकी टोटल कैपेसिटी आ जाएगी 25, U2 इज इक्वल टू 25/0. एंड इसी तरह सप्लाई 3 भी हो जाएगा, और इसी तरह डिमांडेड सारी डिमांड भी पुट कर देनी है, और डिमांड जो टोटल आखिर में आ जाएगी, टोटल डिमांड 1 को कर देना है V1 इज इक्वल टू -5 आ जाएगा, और डिमांड 2 इज इक्वल V2 इज इक्वल टू -9 आ जाएगा, और 30 जो डिमांड 3 होगा V3 इज इक्वल टू 3 आ जाएगा, और डिमांड जो DF होगा V4 इज इक्वल टू -17. और इसी तरह जो टोटल कैपेसिटी आ जाएगी वो 85 हो जाएगी. और इसके बाद नेक्स्ट आ जाता है मेथड. If the condition does not satisfy, then we will use the previous process of addition of and further theta and further tabulation till the condition is satisfied. Presence or absence of epsilon does not affect the solution. So it's up to you whether to retain it is just drop it. So in this situation, when supply is greater than demand, the order to fulfill the demands, we add demand, then we have faced another situation in this particular problem. We are not able to first stage to add the value of u1, u2, v3, v1 and v2 variable. So we added epsilon in one of the variable in order to convert the non-basic cell into the basic cell in order to fulfill the situation of m plus n minus 1. Then जो next आ जाएगा वो optimum transportation आ जाएगा. By using the epsilon, we are able to calculate the value of all u and v variables. Total cost is equal to जो total cost होगी वो हमने निकाली होगी 15 multiply 10 plus 25 multiply 3 plus 5 plus 12 plus 20 multiply 8 plus 5 multiply 20. और इसी तरह इनको जो सब वैल्यू मल्टीप्लाई हो जाएंगी, फिर उनको जो वैल्यू आएगी उस सबको प्लस कर देना है. इसी तरह जो टोटल आ जाएगा वो 545 वो ऑप्टिमम ट्रांसपोर्टेशन आ जाएगी. इसी तरह टोटल कॉस्ट निकालना है, उसको भी सप्लाई 1 और डिमांड 1 वो ऐसी जो वैल्यू हमारी निकली थी 15 आई थी ऊपर, और जो सप्लाई 2 और डिमांड 3 वो भी 25 आई थी, और जो सप्लाई 3 और डिमांड 1 इज इक्वल टू 5 आया था. इसी तरह जो सारी वैल्यू पुट कर देनी है और उनको मल्टीप्लाई करके जो टोटल हमारी फिर प्लस करके जो टोटल वैल्यू निकलेगी वो 545 वो हमारी टोटल कॉस्ट हो जाएगी. And at last, I am going to say that is the case of high supply and less demand. First of all, we take a dummy demand to fulfill the gap between demand and supply. After that, per unit cost is 0 because it is dummy demand, so per cost is 0. We can use a method of m plus n minus 1 and draw a table. Apply the method of a least count in which we consider the least number and add in it. Another problem we faced in it, that variable problem. So we used epsilon in order to calculate the value of variable like u1, u2, u3, v1, v2, v3. So it is a particular situation when supply exceed demand, so we are able to yes Moody method for the solution of this problem and minimize the transportation cost. After this solution, we are able to fix the problem of this situation and all problem relevant like that, optimize the demand and minimize the cost of a transportation. And in the next point, my teammate discuss what happened when the demand exceed from supply. Now it is turn to thanks.
Assalamu alaikum. My name is Mohammad FAROOQ, and my topic is transportation cost with maximization. Next, it can be solved. What happens? The question is what happens? What happens if demand exceeds supply? It can be solved by two methods of maximization. My first method is multiply the given payoff matrix of profit or gain by -1. Then use transportation technique for minimization to obtain optimal solution. And the other method is to calculate the total profit or gain multiply the total cost by -1. The, the question is here like you can see in the slide, and we will move to the solution. Next, introduce to solve the problem, we will introduce a fictitious supply balance row in the question to at 0 point. So it's S1, S2, and S3, and we've introduced SF, a fictitious supply row. The 15 is the difference between the demand and supply. So initial solution by northwest corner rule. We will use these variables like S1, Xij, X in the rows and columns to fulfill to solve the problem. For for maximization, multiply all the profits or gains by -1. You can see that we have multiplied all the profits or gains by -1. Total cost, like we used in the minimization method, we multiply costs uh, all the costs, and we will get the total -745. And total profit, to gain total profit, we will multiply -1 -745 equals to 745. To find the basic variables, we will use m plus n minus 1. M is equal to number of sources, n equals to number of destinations. In this question, we have four number of sources plus 3 number of destinations. -1 equals to 6. Now we will introduce the variables v and u. For calculating the shadow cost, we need to find the values of v and u variables. We will find the values with the equations we are using. U1 plus v1 equals to -10. We will use all these equations to find the shadow costs. To calculate the shadow cost, we will use the formula Vij ui plus Vj minus Cig. V11 equals to U1 plus V3 minus C13 equals to -1 into -1 -20 -10. Like you can see that we have calculated these in the problem. Next, we can calculate all the shadow costs in same way. And in this table, we introduce the loop to find the values. To get the optimum solution, we will use the loop in which we will apply the theta method. In this method, to find the theta value of theta, we will use the minimum value in this loop in this loop, and we will subtract and add in these values. Now we will go to the previous table. Next, total guest, like we are going to introduce the previous method of calculating total cost. It's total cost equals to 15 multiplied by minus 10 plus 15 multiplied by minus 9 plus 10 multiplied by 25 multiplied by 65. The total profit to calculate total profit gain, we will multiply total cost by with minus 1. Minus 1 multiplied by minus 865 equals to 865. This is our total profit. Now we haven't achieved the optimum solution yet, so we will repeat the method again. We will use the equations to get we will use these equations again to get the values of variables. Next, in this table we have calculated the values of variables. So we will move to the next part. U1 equals to minus. Now when U1 equals to minus 1, U2 equals to 0, U3 equals to minus 12, U4 equals to 8, V1 equals to minus 9, V2 equals to minus 8, V3 equals to minus 8. Next. Now we can calculate shadow cost for all cells by using the formula like we used in the previous slides. So we are going to introduce the theta method, and now it's a loop. It's again a loop to obtain the optimum solution because because these shadow cost values are not are positive. So we have to get these values non-positive. So we will add the minimum value in the theta to add and subtract the values. So now we will repeat the method again because we haven't achieved the optimum solution yet. Next. Now we will find the total cost of total cost equals to 5 multiplied by minus 10 plus 10 multiplied by minus 15 plus 25 multiplied by minus 9 plus 25 multiplied by minus 20 equals to minus 925. To calculate the total profit, we will multiply minus 1 multiplied by minus and minus 925 equals to 925. This is our total profit. To calculate the variables, we will use the we will repeat the method of equations to calculate the value of variables. Like here we are using u1 plus v1 equals to minus 10. We have to put a u2 variable equals to 0 to get the values of uh, different variables. Now the loop is we are using the loop to get the positive value to get it non-positive. Next. Total cost equals to 15 multiplied by minus 15 plus 25 multiplied by minus 9 plus 25 minus multiplied by minus 20 equals to minus 950. Total profit and gain equals to minus 1 multiplied by minus 950 equals to 950. So this is all about we are repeating the same method again to achieve optimum solution. Now we will use the same method of calculating values of variables to get the optimum solution. Like you are seeing u1 plus v2 equals minus 15, u2 plus v1 equals to minus 9, u3 equals to v3 equals to minus 20, u4 plus v1 equals to 0, u4 plus v2 equals to 0, u4 plus v3 equals to 0. We will put u2 equals to 0 to get the values of other variables. Now you can see that all the shadow costs in table are non-positive. So we have variables u1 equals to minus 6, u2 equals to 0, 0, u3 equals to minus 11, u4 equals to 9. And in the demand in the destination factor columns, we v1 equals to minus 9. Demand is v1 equals to minus 9, v2 equals to minus 9, v3 equals to minus 9. So criteria for optimality has been satisfied as all the shadow costs are non-positive. So optimal distribution is we will supply S1 to D2 destination to equals to 15. We will supply 15 units to destination 2. We will supply 25 units to destination 1. Source 3 will supply 25 units to the destination 3. Source fictitious source will supply D1 5 units. Source fictitious source will supply destination to 5 units. Fictitious source will supply D3 5 source. Destination 3 5 source. So total is obtained. Total equals to 80. Total gain is equals to 950. So here is our total gain, our profit, because it cannot be maximized more than 950. Thank you. That's it from us.